Hey guys, welcome back to my YouTube channel. In this video, we're going to find the volume of a solid figure using the washers method. Washers are discs with holes. It is also called annulus. An annulus is a flat shape like a ring. Its edges are two circles that have the same center. So in this video, we're going to use R sub I as the inner radius and the R sub O as the outer radius. There are two washer method formula, parallel to x-axis and parallel to y-axis. For parallel to x-axis or rotated on the x-axis, the formula is volume equals pi times the integral of outer radius squared minus inner radius squared from a to b dx. And for the parallel to y-axis or rotated on the x-axis, it is volume equals pi times the integral of outer radius squared minus inner radius squared from c to d dy. Let's have an example. Example 1. Find the volume of the solid form by revolving the region by the graphs y equals square root of x and y equals x squared about the x-axis. So the first thing to do is to graph the function. So this blue curve is the function y equals square root of x, and the green parabola that opens upward is the function y equals x squared. The shaded area is where we're going to find the volume. And this example 1 rotated around the x-axis. As you can see, it has an interval of 0 to 1, from 0 to 1. So the next thing to do is to identify the outer radius and the inner radius. So starting from the x-axis to the function y equals square root of x is our outer radius, and starting from the x-axis to the function to the parabola is our inner radius. How to get its value? So for the outer radius, it equals to top minus bottom. So our top is square root of x and the bottom is 0. So where do we get 0? The x-axis is also equal to y equals 0. Then simplify, so our outer radius is equal to square root of x. For the inner radius, again, just subtract bottom from the top. So our top here is the x squared minus the bottom 0. Then simplify, inner radius equals to x squared. Since example 1 rotated around the x-axis, so this is the formula that we're going to use. So first, just substitute the value of the intervals and the outer and the inner radius. So we have here the volume equals pi times the integration from 0 to 1 times the square root of x squared minus x squared raised to the power of 2 dx. And then simplify it. So square root of x squared raised to the power of 2 equals x, and x squared raised to the power of 2 equals x raised to the power of 4. And next is to find the antiderivative of x and x raised to the power of 4. So we have here x squared over 2 and x raised to the power of 5 over 5. Next is to evaluate the interval from 0 to 1. So we have here the volume equals pi times 1 squared over 2 minus 1 raised to the power of 5 over 5 minus 0 minus 0. And then simplify, so our final answer is 3 pi over 10 or 0.942 unit cube. Example 2. Find the volume of the region bounded by the curves y equals x and y equals x squared when it is rotated about the line y equals 3. So the first thing to do is to graph the function. So we have here the blue line is the y equals x, and the parabola that opens upward is the function y equals x squared. Compared to the example 1, which is it's rotated around the x-axis, and example 2, it is rotated about the line y equals 3, which is parallel to the x-axis. And also, the interval in example 2 is from 0 to 1. Next is to identify the value to identify our outer radius and inner radius. So our starting point will be from y equals 3. So starting from y equals 3 to the parabola is our outer radius, and starting from y equals 3 to the y equals x is our inner ranges. To find the value of the outer ranges and inner ranges, you can use the top minus bottom. So when to use top minus bottom? We can use this if the problem is rotated around the x-axis or parallel to x-axis. So the value of the top is 3 because 3 is in the top of our graph. And the minus the bottom, which is x squared. So our outer ranges is equal to 3 minus x squared. How about for the inner ranges? Again, the top minus bottom, the top is 3 and the bottom is x. So the inner ranges is equal to 3 minus x. So since example 2 is parallel to x-axis, so we use again this formula. So just substitute the value of the interval a to b and the outer ranges and the inner ranges. And next is to simplify. So we can still simplify this. So we have the negative 6x squared plus x raised to the power 4 plus 6x minus x squared. The next thing to do is to find the antiderivative. So we have here the negative 6x cubed over 3 plus x raised to the power of 5 over 5 plus 6x squared over 2 minus x cubed over 3. So we can, as you notice, we can still simplify this. So we have negative 2x cubed plus x raised to the power 5 over 5 plus 3x squared minus x cubed over 3. So the next thing to do is to evaluate the interval from 0 to 1. Just substitute the value of the 1 in the x and then simplify. So the final answer is 32 pi over 3 or 0.867 unit cube. Another example, find the volume of the solid enclosed by the curves y equals x and y equals x squared when it is rotated about the line x equals negative 1. So for last example, it's a graph. As you notice, the given curves, the y equals x and y equals x squared is the same on the example 2. However, it is rotated about the line x equals negative 1 or parallel to y-axis. Also, the interval for example 3 is from 0 to 1. To identify where is our outer ranges and inner ranges, our starting point will be from x equals negative 1. From x equals negative 1 to the parabola will be our outer ranges, and from the x equals negative 1 to y equals x is our inner ranges. Since the problem is parallel to y-axis, but the given curves are respect to x, so we will convert this function with respect to y. So y equals x squared is equal to x equals square root of y, and y equals x, if we convert it, it would be x equals y. So to find the outer ranges and the inner ranges, just use the right minus left. So we're going to use right minus left if the problem is rotated around the y-axis or parallel to y-axis. So the value of the right is the square root of y minus the left, just negative 1, as you can see in the graph. So simplify, so the outer ranges is equal to square root of y plus 1. And for the inner ranges, again, subtract left from right. So we have here y minus negative 1. Simplify, so the inner ranges is equal to y plus 1. Since the problem is parallel to y-axis, so we're going to use this formula. Just simply substitute the value of the outer ranges and the inner ranges and also the intervals, then simplify. So you can still simplify this. And next is to find the antiderivative of so we have here y cubed, negative y cubed over 3 minus y squared over 2 plus 4/3 y raised to the power of 3 halves. And then evaluate the interval from 1 to 0, then simplify. So for example 3, the volume is equal to pi over 2 or 1.571 unit cube. So that's it for this video. If you have any question, clarification, and suggestion, kindly comment it down below.